Assalamu alaikum. Can you hear me? Yep. Okay. So let's get started then. Right. So welcome to the sixth lecture of computer organization. Now we talked in the previous two lectures. We talked about the cycle. If I remember, the lecture before the previous one, we talked about the little man computing, okay? And we had a very simple example of adding two integers to numbers, and we saw how the cycle went through the computer. As I said to you, it's not as simple as for us when we enter an input and we get an output. We think it's just as easy as that. So, for example, if I click on the next slide, so if I want to get the next slide, okay, for me it's easy. You know, I just clicked with my mouse as an input, and I got the output as my second slide. Now it is not as easy as it seems for the computer. In the computer, there's like a cycle going through to give me this output that I see in front of me. Now the little man computing is a very simple representation of this cycle. So we saw like an input, and then the cycle went through, and then an output. In the previous lecture, we did take a little bit more advanced example. So instead of giving you two numbers to add, we had a code, if you remember, a very short code, and we saw, I asked you to, well, I presented to you how to get the instructions for the code. So, and I said to you, it's also not difficult. So if you just if I give you a code in the exam, which will be like similar code, not exactly the same. If I ask you to give me the instructions for the code, then just like I said to you, read line by line. Now always ignore the variables, because the variables, when you create them in your code, they'll be, as soon as you compile, will be stored in the memory. So you do not treat them as an input. They are not input, they are stored in the memory. Unlike doing normal calculations where you have to add two numbers, then obviously you will have inputs. But otherwise, if you just have variables in your code, then it's just like it will be just stored in the memory. Okay. Today we're going to have to look at a detailed instruction cycles. So today is a little bit more not difficult, but it's a more like give you like a more step-by-step instruction cycle, so to show you the details of the cycle. Now, in what does the term fetch mean? The term fetch means it's basically extracting data. نستخلص data, extracting data, while execute هو تنفيذ, apply what you've done. Now the broad diagram for this cycle would be something like that. So let me get my pen out again. Okay. Oops. I always have problem with this pen. It doesn't seem to go well with me. Right. Okay. So if we look at the broad picture, or broader diagram, so the steps of doing the fetch and execute cycle will be something like that. So first of all, we're going to have to fetch the data, meaning, fetch the instruction, meaning that we need to know what the instruction is, or the computer needs to know what is the instruction. Okay, so we do fetch. After doing the fetch, we do decode. Okay, we do decode, meaning that we need to analyze the instruction. So we get the instruction, and then we need to analyze what the instruction is. After the computer analyzes what the instruction is, it will basically just do execution. It will execute the instruction. So we have execution. Or execute. Okay? Right. So this is just like the broad diagram, the broad picture of this cycle. Now let me introduce you to a diagram. As you remember, we talked about the determined computing diagram, and we saw how the diagram was. Now today we're talking about a different diagram. It's designed by someone called von Neumann. So it's called von Neumann architecture. So it's a design that was done by von Neumann that shows the memory, okay, and it shows the CPU with the very important, or the three main parts. Now I'm going to open the chat now, and you tell me now what does the I/O interface is? What is the I/O interface? Input output. Yes, it is input output. You're going to have to input data, and you're going to have to get the output. Now, what does the term ALU mean? What does the term ALU mean? Not buses, no. Right, okay. RAM, not RAM, no, okay. Let me ask. By the way, today, logic, yes, yeah. Arithmetic, logical, yes, thank you. That's you've got it right, Adela, you've got it right, yeah. Right, by the way, today's lecture, I'm going to give you a lot of terminologies, or quite many terminologies, so you're going to have to write them down, okay? Because in the slides, I've given you the short terms. So today I'm going to just give you many terminologies that you need to understand, you need to remember, and you need to write down, obviously. So the ALU stands for arithmetic logic unit. Okay? Arithmetic logic unit. What does it do? What does it do? Yeah, it does operation. It does all the calculations for us, the normal calculations, plus, minus, and so on. It does the logical calculations. What do you mean by logical? When we say a logical operation, what do you mean by logical operation? Yeah, not plus or minus, no. Logical operation is could be comparison, maybe Boolean, yeah. We're talking about true and false in here, okay? We're talking about true, false, 0, 1, and so on when we talk about logical, okay? Thank you for your contribution. Now, again, the final main part, which is like a device divided into two, we have the control unit that reads and writes the data, and we also have a program counter which will determine which instruction to fetch and execute next. Okay, so let's go into details. Okay, this is what I've just described for you. Now, this diagram is quite important. Now, in the exam, I will not ask you to draw this diagram for me, because it does look rather tedious for you to remember, but I want you to understand it, because if you do understand it, okay, I will ask you in the exam, if I do ask you, I will ask you to draw this for me instead, okay? So I'll come to this in a minute. Let me explain this diagram for you. So this is inside the CPU, we have the memory here, and by the way, have a look. Do you remember at the beginning of the lectures when I said to you, at the beginning of our course, I said to you always the memory and the CPU are best friends. And I said to you, I always describe the computer just like the human, okay? It has a hardware and software, as the human has the hardware and software. It also has a memory. The people, the human, have memory. It has a CPU, which I always say the CPU is the heart of the computer. So, and always, even in the Quran, you'll notice that the heart and the brain I kind of mentioned together. So even in the computer, the CPU and the memory are always kind of, they go together. They communicate a lot between each other. Okay, so let's take a look at this diagram. So you have the CPU and you have the memory. Now, right. If we have a look, okay, I'll explain these terminologies for you in a minute. Now, look at. I want to highlight this out for you. Now, look at this that says bus. What is the bus? What is the bus? The pathway. Yes, that's right. Yeah, pathway. Just like we call hafilat, we call them buses. Okay, because they are used for transferring people. Okay, we call them buses. So it is, and look how it is connecting everything. Okay, so this is just like كأنه شريان في الجهاز. It's like connecting everything for you. But obviously, if you see a bus moving, and it stops, you cannot jump inside the bus from the window. Okay, you need to go through the door. Similarly, the bus in the CPU, it has gates to allow input and output from and to the bus. So these are the little ones. These ones are gates. Okay, they allow input and output from various devices. So gate number 0 to 12 and 7. They allow input to the bus. They allowed input to the bus. While gate 5, 6, 4, they allow output from the bus. Okay, and so on. So these are the little ones, are little gates that allow input and output to the various devices. Now, what I will do, I'll jump straight into the whole idea of this chapter. I want you to know the detailed cycle, okay? I am not even interested in these gates. You know, this is called a multiplexer, a multiplexer. I haven't introduced this to you, so I will not obviously ask you to do it. Multiplexers are combinational circuits. I don't know if you've studied logic or circuits before, or logic gates. Maybe you have studied logic gates from, maybe you either studied logic or you either studied discrete mathematics. You did come across logic gates. Now, the MUX is one type of a combinational circuit. So basically, if you combine different logic gates, you will get this MUX or multiplexer that allows various inputs, 2 inputs or 4 outputs, and then it will give you. It will allow more than 1 input, like 2, 4 inputs, and it will give you an output. Okay. Anyway, I'm not interested in these because I haven't explained them to you. So we'll don't worry about them. We'll skip them. So I'm interested in this. The whole idea of this lecture is I want you to know the detailed instruction of this cycle. Now, well, these diagrams these notes are just explaining some of the stuff like as I said, but never mind. I'll explain them as I go along. Now, this table is quite important. If you notice, these are the gate numbers, the little ones, okay, and the operations that they allow. Okay, they are linked to these operations. So these are the gate numbers and these are the operations. I want you to memorize these. Okay, so I want you to know these. So in the exam, I could well ask you, what does gate number 4 do, for example? Okay, so you need to know this table for the exam. Right. Okay. So let's start with the main thing that I wanted to talk about is the cycle. Now imagine we want to add 2 numbers. For example, 4 plus 5. Okay, if you want to add 2 numbers, for example. Now let's see how the computer will deal with these 2 numbers. First of all, we have something called the PC. It's not a personal computer, no. It's called PC. It is a program oops, it's a program counter. A program counter. What does the program counter do? It'll decide which instruction will go next. Okay, so it will decide the instruction. Okay, so the first thing that the PC will do will go to the bus and it will ask you, is there anything in the memory for us? Imagine that you're working in an office, okay, and you have no work, right? And then you, I don't know, you call your colleague and say like, have you got some new work to do? Okay, so the colleague will tell you, which is the MAR, okay, it will tell you the address where to get the new instructions from, okay, MAR. So by the way, before I continue, imagine, right, I'm going to write it down here. This is the memory, do you remember? Okay, this is our memory. Okay, do you remember that we've taken this before? Now, what do we have in the left hand? I'm gonna open the chat for you, and you tell me what do we have on the left hand side of this memory? What do we have on the left hand side? Address. Yes, thank you. What do we have on the right hand side of the memory? What do you have on the right hand side here? What do you have in here? Number of operation? Yes, I know what you mean. Yeah, but imagine that the number of operation, imagine that the whole code goes in here. Okay, the whole code goes in here. What do we have on the right hand side? We have the data. Okay, so this is the address, this is the data. Okay, let me explain. Okay, so the program counter will say, okay, then do we have we have an instruction. What is the location for the data that we have? So it will communicate to the MAR through the bus. Now, what is MAR? MAR, it's memory, address, memory, address, registry. Okay, memory address registry, which means that it holds the address of the data that we want to work on. For example, so if we have number 4 that we want to work on, if we have it, let's say location number 7. So we have, if we say this is address number 7, for example, and the data is here. Okay, so this is the MAR. Now the counter will ask, okay, then where is the address for the data? Now, so the MAR will be loaded. Okay, the address will be loaded. Say, for example, 7. Now it will be incremented. Inc means increment. Inc means increment. Increment, which means idafa. Increment means idafa. We're adding to the counter, so the counter now has some work to do. So okay, then we have an address. We increment it. We add it to our PC. Okay, we add to our PC. Then we load it. So now number 7, which is the address, is known to the PC. So the PC knows that, okay, then the address is number 7. Now comes the CS. The CS, which we talked about here, the CS, which is this device that I showed you just now, the CS is the control signal. Now, again, what is the job of the control signal? You ask me. You tell me. Sorry. What is the job of the control signal? What is the job of the control signal? You can tell from here. You can tell from here. What did I say about the control signal? Read. No. As I said to you, control signal does read and write. Yeah, that's right. Read and write. That's right. The control signal's job is to read or write data. Okay? Now you tell me, up to this point now, when we got the number 4, is the control signal, is it going to read or going to write? Is the control signal, up to this point, the person who said read, correct, write is wrong. Yeah, it's going to read. We haven't got anything to write yet. Okay, we don't have anything to write at the moment. We are trying to read where the data is. Okay, we haven't got a data to write. We are trying to fetch. So far we are fetching. We are getting the data. So now we need to read. What is the data? We need to read it. So to read it, now we go to the right-hand side of the memory, which is the MDR, which stands for memory data registry. Registry. Memory data registry. Now it is in here. It holds the value in DR is here. It holds the value. It holds the value basically. So we have the address on this side and the corresponding value on the right hand side. Okay. So now we got we know now we have number 4. So we got the 4 here. Now we load this number 4. We load something called IR, which is here. We load something called IR. Now what is IR? IR is instruction registry. Instruction registry. Okay. Now, what is the job of the instruction registry? Let me go back to that figure. Okay. What is the job of the instruction registry? Now, the job of the instruction registry is to store the data that we got for a very short period, very temporarily. Okay, so it will store. So we got number 4. It's transferred through the bus, through gate number 4. It's gone to here. So we've got number 4 here. Now it stores it for a very short period until we know until the computer knows what's going to do with it. Okay, until the computer knows what is going to do with this number 4. Okay, or we might even have like a queue of data here. So as I said to you, do you remember when I told you, if you open, for example, 10 applications in your computer, 10 applications simultaneously, one after the other. You know, if you click 10 applications, Internet Explorer, Word processor, Excel, and so on, you will notice that your computer will slow down. Why? It's trying to do all the instructions. Every time you click a mouse to open an application, you are given an instruction to the computer to perform a task for you. So when you have too many tasks, the computer will slow down because the computer will try to solve them one after the other. So you'll have a bit of queue. Same will happen here. Okay, you might have different data being fetched. Okay, so you might get just a little delay in the IR. You have a queue. That's one thing. Or it's just like it's having number 4 and it's just waiting for the instruction. Okay, I have number 4 in my hand. What do I do with it? Okay, so it will be stored for a very short period. Then after we know what we're going to do with it, or after it comes to its turn, it will go to the decoder, which is the second block of the cycle that I showed you at the beginning of the lecture. So the second block, the decoder. Now it will analyze number 4. What is number 4? Okay, it will analyze it back to the binary, or what do I need to do with it, and so it will analyze number 4 for us, the data for us. So that's the decoder. Okay, and then the decoder either gonna give an output, either read or write, or gonna give it to the address, back to the address. We'll see. Okay, so let's go back. Okay, so we load it to the IR, right? By the way, up to this point, before we get to the decoder, up to this point, okay, this is the fetch. This is the fetch step. Okay, so this is, so far we've only done the fetch. So up to the load to the IR is only about fetching. We're getting the data, right? Now this one here is the decoder, and the rest obviously is the execute. Okay, I'm not going to write it. The rest is the execution. So now it's let's say with our example, we're going to have to load it back to the address. Okay, so we've got number 4. We need to load it back to the address. Do you remember when I said to you when we type in 2 numbers, for example, on the calculator, you type in number 4, then plus, then number 5. Now, if you do that, what will happen to number 4? If you do that, what will happen to number 4? So you have a calculator, you press number 4, then plus, then number 5. What's going to happen to number 4? Do you remember? Goes. Where does it go? Saved. Yes, of course. It has to be saved. If it's not saved, the data will be lost. Okay, if it's not saved, the data will be lost. So yeah, it's going to save the number. Now, okay, so load it to the MAR, go back to the address. Right. So now the instruction will, the diagram will ask us, or will ask the computer. Now, this output that we have, does it need storing? In our case, yes it does. Okay, in our case, it's number 4. Okay, yes it does. So it's going to accumulate. Don't worry about the accumulation. Now it's going to accumulate to the bus, add to the bus, and then load the NVR. Okay, so it's gonna load it to an address. So this data will be loaded to address, either the same address, or it could be given in a different address. Let's say number 20. Oops. Let's say. Let's stop again. Yeah, let's say number 20 or whatever. Whatever it is told to. Now, you tell me the control signal. What's gonna do? Let me open the oops. By the way, my pen stopped working now. Okay, you tell me the CS. What will the CS do now? Yes, it will write. It will write this data to the memory. Okay, it will write this data to the memory, and then we will go to the next instruction. Now, the job of the ALU, it will tell us that we have an addition. For this example, it's going to have an addition. Okay, so we need to get the next number to add to. Okay, so we have number 5 now. It will go exactly the same cycle until we get to here. Now, do we need to store number 5? Do we need to store number 5? No, because we will add it straight to the stored number 4. Okay, so we'll say no, we don't. Okay, now what will the CS do for us? What will the CS do for us? It will write it for us. Okay, it will not read it for us. It's already read it in here. Where did it read it? It's already read it in here. Okay, now it's gonna write it for us for addition. Okay, so it's gonna write it for us for addition. Now, it's asking you, is the output needs loading? Do we need to load the output? In our case, no, we don't need to load the output. It's there, it's written there, depending on what the instruction is. Okay. But in our case, no, we do not need to load the output because it's already written for us. We don't need to load it, so it's going to straight go back to the value. It will use the ALU to addition, okay, and so on, and then we'll give the output for us, and it will add it. It will add it to the accumulator for us, okay. So it's going to add it for us, okay, and then that's how we finish the cycle, and then the computer will go and ask, do we have another instruction? And this cycle will repeat forever until you switch your computer off. Okay? This cycle will never stop. The moment you turn on your computer, when it starts booting, these instructions will keep running. You have various applications that run on your computer, various calculations, and this cycle will keep going, dealing with all the cycles. Now again, if you have an overload on your CPU, it will slow down your computer because obviously it needs time to process everything. Okay? Now, that's the main thing that I wanted to show you in this lecture. Now it's showing us here the fetch and execute. Obviously, it included the decode that's execute. Doesn't matter. I call it decode. You know, it doesn't matter really. I call it decode. Doesn't matter. You can class it with you can combine it with execute. It's fine. And these diagrams, okay, which I already explained to you, they show you the step-by-step instruction that I just explained to you now. So the red color will show you what's happening right now. Sometimes combine more than one instruction in one slide. So go through them and have a look at the rest of the instructions that I explained to you already. So see how we deal with them. Okay, so that's the end of our lecture. If you do have questions, please ask. I'm gonna turn off the chat. If you do have questions, please. Someone asked me, what does the ACC mean? It means accumulator. ACC. ACC means accumulator. I think it's an I. Accumulator. I think it's written this way. I'm not sure about that. Accumulator, E or I, anyway. Okay, so accumulator. It means أضيف. يعني شغلة أضيف. أضيف لنا على الانستركشن تاعنا. Okay, so أضيف لنا accumulator. أضيف لنا على الانستركشن. فبعد ما خلصنا الناتج النهائي ضافوا عندنا أنه عندنا ناتج نهائي ضافوا عندنا على السايكل. Okay. Now, any questions? Please raise your hand. Any question? You don't have a question? You sure? So you understand everything? So who understands everything then? Put a check, because I can't believe like a whole class will not have a single question. Who understands? Okay, there's one person who doesn't understand, so ask me. Don't be shy. Ask. Now, hang on, I need to clarify this. Now, I have 25 students in this room. Do you understand? Either yes or no? Come on. Yes or no? Okay, go on. 10. It shows that probably most of you like just register your names and you're not on your computers maybe. Okay? Okay, finally, we have one question. Right, speak. Yep, Munira, I think. Why did you put your hands down? Munira, yeah. Ask.
Yeah, Doctor, I would like to ask you not about the section. It's clearly too much, but I would like to ask you about the section that will include in our midterm exam, because in the Blackboard they say until week 7. So what's the chapter that will include with us? Maybe I will include the next 2 chapters. So it'll be next week, which is chapter 7, and the week after chapter 8. Don't worry about the exam. Again,
again, I'm going to repeat this to you. I did say it in different classes, sorry. The exam, I will prepare you for the exam 2 weeks before the exam, okay? Don't worry, we have about 3 weeks left. So a week or two before the exam, I will prepare you for the exam. I will tell you exactly the chapters that are included in the exam, and also the kind of questions you might get. I'll give you practicing questions to try at home as well. So don't worry, I will prepare you for the exam a week or two before the exam date. Okay?
Yeah, but we ask you because you wanna start study because there's not.
Start study. Start now. You have 6 chapters. Now you have 6 chapters. Start study them.
From 1 to 8, yeah.
From 1 to 8.
To 8. Okay, thank you.
Yeah. Okay.
Thank you.
Any more questions? Any more questions? So I take it to understand. Although there's one person who put a cross, meaning there's something that they don't understand, it's your chance to ask me now. Okay? Now, if you're not comfortable to talk, that's fine. Send me an email. Okay? If there's anything that you don't understand, send me an email. There's Muna. Right? Ask question. Muna?
Hello, doctor.
Hi.
I would like to ask you about this cycle. It happens in the CPU, inside the CPU, or in the whole motherboard, or where exactly?
Inside the CPU. Right, let me go back to the first diagram. Here we go. Right, inside the CPU, we've got the memory connected, obviously, because we need to get the MAR and the MDR, okay, from here. But everything else is happening inside the CPU, okay? Another question? Another question? Okay then, so I take it that you all understand. If there's anything that you do not understand, please send me an email. Now there's a weekend coming, so I urge you to catch up if you have missed anything, or if there's anything that you're not sure about, you don't understand. You've got a weekend. Please start studying. The exams are approaching now, and I'm sure you have have quite a few probably subjects. You have 5 or 6 subjects each. So do please, you've got like 3 weeks probably left for the exam. So it's not a very long time. So make sure that you catch up with anything that you do not understand. And for me, you can always email me. And also the good thing is you have face-to-face lecturers as well. So wherever you are, so now all the branches of the universities are covered with lecturers from next week. So if you haven't had a face-to-face lecture so far, I'm sure you will have next week. So as from next week, all the face-to-face lectures will start running. So this is a very good advantage for you. If you do have a question, you can either email me. I'm always available for anyone to ask, or you can ask directly your face-to-face lecturer as well. And so make use. You have good tools. You have the blackboard. You have the slides. You have 2 lecturers teaching you. So you have quite good tools that you can use. Make sure you use them. Okay. Excuse me. So that's it for today, and I hope you have a very good weekend, and I'll see you inshallah next week. Goodbye.